Okay, let's see what you remember from Math 1 on the different features of functions. So, like we highlighted in our notes today, there's certain ones that can be done together that'll save you time because your brain's already programmed for thinking along the lines of looking at the x-axis or looking at the y-axis at the same time. So your domain are your x values from left to right on the graph. And your domain can be broken into parts of increasing or decreasing sections. So looking at those all together can be helpful. Again, down here, the domain and the increasing and the decreasing sections, that can be helpful. Then also, it can be helpful to look at the minimum and the maximum at the range at the same time. Okay, so when I'm looking for the domain and the increasing and decreasing sections, I'm going to be using the numbers along the x-axis. So let's highlight that as well. So what is the domain of this graph? Since this is a connected graph, I could trace it the entire way. It's continuous. I can say that there is one domain. It goes all the way across, starting from here, all the way across and stopping here. Well, what does this little arrow signify? This means that it goes on forever, and that means into the direction of infinity. Well, when we're talking about infinity going how far left, we're going to call that negative infinity in the negative direction. And it's going to be going all the way to the right until what number? We look up to this x value of 3. So we're going to say that the domain of this function goes from negative infinity up to 3. Now we're looking at what brackets should we put on that. Because this is infinity, it's a number that can never be touched. We're going to put an open bracket, not included. And because this is an open dot over here at 3, we're going to do open bracket, not included. We're using interval notation that you learned in Math 1 to do this domain. Now, which of the sections are increasing and decreasing? There are 2 sections that are going up from left to right and 2 sections that are going down. We're going to use open brackets for all increasing and decreasing sections to signify what's happening in between 2 points as going up or going down from left to right. So let's look at this first section. If I was walking across this graph from left to right, I would be walking in the upward direction. So I could say that the piece of the domain that it's starting with is a piece that is going up. So from negative infinity till 4, it's increasing. And then from negative 4 to negative 1, sorry about that negative, it's decreasing. Then it starts at negative 1 going up again from negative 1 to 2. And then it starts from 2 to 3 going down again. So it's almost like I'm looking down and up at the axis. I'm looking down to see what x value that's at. This one lands right on the axis. I'm looking down at the x-axis to see what's going on there, and then I look up to get that value right there. So you're always referring back to that highlighted x-axis for the domain increasing and decreasing. Now let's go do the min, max, and the range. For the minimum of the graph, it's the lowest point of the graph. This is sort of a fake out dot here. First of all, it's open dot, which means it's not even included, but check out this arrow. This arrow means this goes on forever, and when it goes on forever, there is no minimum of the graph. Minimum. And when there's no minimum, some students like to write that y goes to negative infinity. But you don't need to write the y going to negative infinity part. You just need to write no minimum. What about the maximum of this graph? The maximum of this graph is going to be written as a y equals equation because it's a boundary of where those top points hit. And so what is the equation of that boundary line? It goes through 4. So we say that the maximum is at y equals 4. You could say that these 2 dots exist on that boundary line, but you're not going to say that the maximum is negative 4, 4. You're not going to say that the maximum is 2, 4. You're going to say that y equals 4 is the maximum using the y values. Is this a function? Doing the vertical line test, it only touches once in all places. Yes, it is a function. For every x, there's only one y. Let's take a peek at the second graph. Is the second graph continuous this time? Nope. Not connected that I can trace the whole time. Is it discrete dots? Sort of. It's something weird going on here. When it's part, a little bit of both, like there's some connected lines, there's some gaps in between, we're going to call this graph discontinuous. But is it a function though? Yes, because for every x there's only one y. Let's check this out. Here's a point of interest right here on this dot at -7. Even though there's an included dot here, when I look straight up, it's not included there. So we don't have an issue here. Let's look at this area of interest. When there is an included dot here, I look directly down and there's not an included dot there, so I'm good. Let's look at this area. Nope. Let's look at this area. So yes, it is a function. For every x, there's only one y. What's the minimum of this graph? The lowest point? In this case, is through y equals -8. What's the maximum of this graph? The boundary line of that highest point. It's through y equals 4. If you get the minimum and you get the maximum first, when you go to do the range, it's so easy because the range is literally the min to the max of your graph. So let's go right in that range from -8 to 4. Now let's look at whether we need closed or open brackets. Is this dot closed or open, included or not? It's included. Let's make it closed. Is this dot closed or open, included or not? It's included. Let's close it. All right, let's identify any areas of increasing intervals. First one, if I walk across the graph, this is going down. So from -10 to -7, it's going down. Use open brackets for all increasing and decreasing. This is going flat, so we're going to talk about that in a second. From -2 to 4, it's also going down. And those are my two areas of decreasing so far. What does this little U mean? It means union or and when you're trying to include two sets that are decreasing. That's what that U symbol stands for. Identify any increasing pieces. Well, here's a section that's increasing from 5 to infinity. Open brackets always for this. And I'm going to write in the constant because there is a section that's not going up or down, it's just flat. So going from -7 to -2, we call this the interval constant. We didn't ask that one, we should have. Last but not least, let's go back and do the domain, of which all of these are pieces of. Again, looking left to right on that x-axis for the domain. So what happens? The graph is going, but then it starts right back up there, going, but then it starts right back up there and goes, but then wait, there's a huge gap. So these separated sections of the graph are actually one domain going from -10 all the way up until 4. We're going to include the first value at -10, and we go look at the 4 and see a closed dot also, so we include it. But then there's a gap in your graph where any of those x values in between 4 and 5 are not included. So start back up again at 5, that goes to infinity, and notice the open dot there, so we do not include the 5. Last but not least, neither of these graphs asked for the x and y intercepts, so let's just go take a peek at what those would be. Here, the places where we touch the x-axis for the x-intercepts, the y is 0. There's 3 of them. There's -10, 0. There's 0, 0. And there's 7 what would you call that? 7.30 for the y-intercepts. The x is 0. Where do we touch on the y-axis? Only one spot at 0, 0. Sometimes x and y-intercept are the same because they're both the origin. What's the x and y-intercepts of the top graph? X-intercepts are where y equals 0. So here we go at -7, 0. -1, 0. Call that 2.3. And then your y-intercepts, 1.5 maybe. do your best to estimate that. Okay, I hope this gave you a quick review of features of functions, but please know that if you still feel like, ooh, I'm shaky on this, that we are going to be doing a huge lesson on it in Unit 1 coming up starting next week. We're going to go over each of these items in depth again if you need it. Thank you. Thanks for listening.